Betelgeuse is one of the brightest stars in the sky and one of the largest stars known to astronomers. It's the second brightest star in the constellation of Orion and marks the hunter's eastern shoulder. Its name is derived from an Arabic term that translates to giant's shoulder or giant's arm or something of the sort. Because of its brightness, it's likely that even the earliest humans were aware of Betelgeuse. It appears in the myths and stories of many cultures across the world. Many of these refer to Betelgeuse as a part of Orion, which is named after a hunter in Greek mythology. The ancient Egyptians, on the other hand, included Betelgeuse in their constellation Osiris, named after their god of the underworld. Betelgeuse is one of the most luminous stars in the sky, and it's classified as a semi-regular variable star. This means its apparent magnitude, or how bright it appears to be, varies, but it's generally around 1.6. It's very easy to spot because of its brightness, its position in easily one of the most recognizable constellations, and its deep reddish color. In 1603, German astronomer Johann Bayer gave Betelgeuse the designation Alpha Orionis. Bayer designations usually go by the brightest stars in the constellation, with Alpha referring to the brightest one. Betelgeuse still retains this Latin name, even though Rigel is usually the brightest star in Orion. Betelgeuse is about 650 light-years from Earth, though its exact distance is hard to estimate. It's usually the 10th brightest star in the night sky, but its periodic dimming and brightening sometimes makes it climb up or down a few spots. Betelgeuse is a very impressive star, having a diameter of more than 700 million miles, having surface temperatures of up to 5,800 degrees Fahrenheit, and shining 7.5 to 14,000 times brighter than the sun. Because of its size and relative proximity, it's one of very few stars that can be studied in greater detail by telescopes on and around Earth. Up close, Betelgeuse looks like a sort of lumpy clump of boiling gas bubbles, and some of these bubbles can be as large as a small star. Plumes of hot material rise from its core to the surface and then cool and fall back down. In 1863, astronomer and mathematician Sir John Herschel documented Betelgeuse's changing brightness, but he probably wasn't the first one to notice it. There's evidence that the variability of Betelgeuse and other red giant stars is described in Aboriginal oral traditions. Its brightness usually varies with two different periods, one lasting about 400 days and another lasting about 6 years. It's these cycles of dimming and brightening that are at the heart of some of the biggest mysteries about Betelgeuse. Betelgeuse is a red giant star. This means it's in the final stages of its life, no longer in the main sequence phase, and this fact sometimes prompts speculations that it will soon go supernova. Because it's so big and massive, Betelgeuse has burned through its fuel very quickly. It's only 10 million years old or so, hundreds of times younger than our sun, but it has already exhausted its supply of hydrogen. Betelgeuse was probably born as a very massive star. It used to be a blue-white O-type star, the most massive kind in the main sequence category. In its prime, it might have been tens of times more massive than the sun, tens to hundreds of times more luminous, and had surface temperatures of close to 90,000 degrees Fahrenheit. If, or rather, when Betelgeuse eventually goes supernova, it will be bright enough to see during the daytime. Its brightness will match the full moon, and for an entire 2 months, you could probably read a book by the light of the supernova alone. However, it's unlikely that Betelgeuse will actually go supernova during our lifetimes. It's only in the early stages of its red giant life. The ancient Greek astronomer Claudius Ptolemy described the star with a Greek word that means a color that can range from a pale yellow to a light reddish. Similarly, it was described as a yellow star until about 2,000 years ago, when poets began to describe it as red instead. So it probably hasn't been a red giant for very long, and it's still got plenty of time left as one. In December of 2019, Betelgeuse suddenly grew 2.5 times fainter than what had ever been seen from it before. It was known to vary in its brightness, sure, but this was unheard of. This event was so significant that it became known as the Great Dimming. The most likely explanation for the Great Dimming involves two big blobs of fluid colliding with each other within Betelgeuse. This extremely rare collision sent a lot of material towards the surface and drove shockwaves ahead of it. When this material reached the surface, a lot of it just burst right out, but some started to fall back inside. This resulted in a huge dust cloud that obscured the star and appeared to dim its light. Basically, Betelgeuse threw up a whole bunch of material, and that stellar vomit then sat between it and Earth and made it seem dimmer until it dissipated. I guess even stars get food poisoning sometimes. There has long been speculation that Betelgeuse might not be a single star. In 2025, astronomers proposed that its 6-year variability period could be caused by an unseen stellar companion. This companion would likely be a pre-main sequence star, so one that isn't fusing hydrogen in its core, and it would orbit in the extended atmosphere of Betelgeuse. If these estimates are correct, then it would be expected to spiral into Betelgeuse sometime within the next 10,000 years. Along with this proposal, the formal name of Siwarha was suggested. This is an Arabic name translating to her bracelet, but it's also been known by the much sillier name of Beetle Buddy. This companion star, which I'll just call Siwarha for simplicity's sake, is probably too small and faint to be seen when it's so close to Betelgeuse. Just earlier this year, a team of astronomers announced some of the most compelling evidence for its existence yet. Over a period of 8 years, a series of observations revealed the possible effects of Siwarha. There appears to be a trail of gas moving through Betelgeuse's extended atmosphere, where Siwarha probably orbits. It might stir up the extended atmosphere as it orbits, thus leaving a wake that impacts what we see from Betelgeuse. It's important to note that this isn't a direct observation, and as far as I can tell, Siwarha hasn't necessarily been proven to exist. You usually need a direct sighting to do that, although with a small companion next to such a big and bright star, that would be hard to achieve. But it's still very interesting and a pretty strong argument for the companion star's existence. Maybe Betelgeuse isn't alone out there after all. Even if it doesn't happen in our lifetimes, Betelgeuse will eventually go supernova. That's just the fate of any star of its mass. It could take as long as 100,000 years for it to finally explode. Beyond that point, it'll either become a neutron star or a black hole, depending entirely on how much material is left after the supernova. It would be cool to see Betelgeuse go supernova during my lifetime. It probably won't, but it would be neat, though I do feel like I'd miss it a lot. I hope you enjoyed learning about Betelgeuse. It would be much appreciated if you could leave a like and a comment, and of course you can subscribe if you want to see more. Thank you very much for watching. I hope you have a good day, and I also hope to see you next time.